Okay, all right. So now we go to the next video. Okay, so the next video will tell about the kind of maps. Okay, with the expression of x. Okay, what is actually the expression of x? Okay, some of the logic circuits may be designed so that the certain input conditions have no specific output levels. Okay, usually it's because of this happens when your input conditions will never be occurred. Okay, dia tak pernah wujud pun. Okay, alright, so that's why in the other words, there will be a certain combination of input whereby we don't care whether the output is 1 or 0. So maknanya dia tak kisah pun sebab dia tak terlibat pun dalam operation tersebut. Okay, because of the combination of input tu, okay, dia ada tapi dia tak ada output apa-apa pun. Okay, the output, okay, tak ada specific output of 1 or 0 because the combination of input tu doesn't makes any logic for that particular circuit. Okay, alright. So for example here, okay, let's say for example kita nak kesan nombor ganjil, okay, when you consider a logic circuit that will detect an odd number for the BCD code. Okay, remember your binary code decimals, okay, so your binary code decimals ni, they have only numbers of 0 to 9. Okay, so in this circuit, okay, they have a 6 input numbers which is they are not used. Okay, so, contohnya BCD alright, binary code decimal ni dia antara 0 hingga 9 saja. Okay, and then dia punya input only dia 4 bit 0000 sampai 1001. Okay, untuk 10 ke atas dia tak ada. Okay, dia tak digunakan. Okay, sebab kalau kamu tukar 98 pun, okay, of the decimal number, so dia jadi 1001 and then 181000 BCD. Okay, dia tak ada nilai dia sendiri. Okay, so therefore there's not being used lah. So jadi 1010, 1011 and 1100 ni untuk 10, 11, 12, 13, 14 dan 15 it never been used. Okay, so kalau kita design satu letar yang mengesan nombor ganjil with the binary code decimal, maka with the 4 inputs, okay, kita tekan nombor, okay, so that kita boleh tahu sama ada nombor yang kita tekan tu adalah nombor ganjil atau tidak, okay, as a output. Okay, so therefore kita can generate the truth table lah. Okay, untuk input ABCD kosong, okay, kosong dia kosong lah. Satu nombor ganjil tak? Okay, yes. So dia akan menyala. Dua nombor genap. 3 nombor ganjil, on. 4 nombor genap. Okay, kosong. 5 ganjil, on. 6. Okay, 6 dia adalah bukan nombor ganjil, nombor genap. 7, yes, dia on because dia nombor ganjil. 8 nombor genap. 9 nombor ganjil. How about 10 and so on? Sebab you pakai BCD, so BCD dia up to sampai 9 je. Because of your input ni ada 15, so yang 10, 11, 12, 13, 14, 15 ni tidak diguna pakai. So therefore, we represent that this not being used ni as X. Okay, X expressions. Okay, so X expression lah. Okay, so the truth table as a follow. There are 6 don't care terms which is labeled as a X. Okay, we don't care about the result. Okay, because they're not being used. Okay, for that particular circuit. Okay, so when we map into a Carnot maps, okay, so Y, okay, so you transform of the logic one, okay, only the logic one into the Carnot maps. Okay, so which is 1, 3, 5, 7 and 9. Okay, so 1, 3, 5, 7 and 9. Okay, how about 10? 10 kita letak X, 11 letak X, 12 letak X, 13 letak X, 14 letak X, 15 letak X. So how we want to simplify, okay, this expression. So since they have X for the expressions, okay, in the Carnot maps, so when we draw the loops, we can include, okay, the we may include the X expressions in your loop punya consideration nanti. So for example here, where you draw the loop of circle of the the loops, okay, because we want to get the biggest loops, okay, to get the simplified of the Boolean expression as you can. So you got the biggest loop, which is 8 here. So the 8 loops here, you can combine including the X expression. Boleh, tak ada masalah. So how about yang ni, kita biarkan saja. Okay, kita biarkan saja. Ignore, dia tak digunakan pun. We don't care about that. Okay, so yang X yang terlibat dalam loops, okay, then we can consider X as a use. So therefore, yang ini, so the expression is, okay, so this one habis. So this one C bar and dot D and CD. So C bar and C habis. So therefore, your expression Y equals to D. So maksudnya di sini ialah, even you have the X expressions, okay, we can put into the K maps. And then when we draw the loops, okay, if you want to, if possible, you have to include the X is exception. Dikecualikan, dibenarkan lah, okay. Alright, so for example here, kita buat exercise sikit, okay, on the K map, okay, of the K map here. Alright, so I just take from the example of the questions here. Okay, so from soalan exercise dalam notes awak. Okay, so kita draw the loops. Okay, kalau dia ada X, when they have the X of a don't care punya expressions, so draw the loops. Okay, we draw the highest loops. Okay, so draw the highest loop here. Okay, this one. Okay, saya ambil yang lain. And this one. Okay, alright. So now we draw the expression for each particular loops. Okay, so the green one we have. So kita boleh masukkan X as good to complete, to fulfill the simplified Boolean expression. Boleh. Okay, so A bar, this column and this column. So A bar dot B bar and A bar dot B. So kita boleh hapuskan B bar and B. Alright, and then C bar dot D and C dot D. Okay. C bar dot D and C D. Okay, so you have C, kita matikan. So you have A bar dot D. Okay. Okay. And for the blue loop, the blue loops ni, okay, so since they use a vertical of adjacent cell here, so therefore the answer is A bar dot V bar. So your expression is Y equals to A bar dot V bar plus A bar D. Right? Sama juga dengan soalan yang ni, yang K ni. Alright, so you can draw the expressions here. Okay, draw based on these loops. Kita boleh ambil dia sebagai 4. Boleh, sebab dia X ni kita combine dia jadi ni supaya untuk fulfill, to get the simplified as you can for your Boolean expression. So now you draw the loops. Okay, because this involve these 2 column and these 2 row. So A bar and A kita boleh eliminate. So you have a B bar. Okay. And then C bar and C, alright, also it's being eliminated. So therefore your Y equals to B bar. Okay, alright. So when you draw the condition of the truth table, dia akan inform biasanya for expression that not being used. Okay, alright. So dia kata ignore of the ignore the situations, okay, other than of the given yang dia bagilah. So ignore maknanya express of S lah. Maknanya dia not being used, it not being used. So the certain of input tu dia not being used, so maknanya kalau not being used, okay, maknanya not fully utilized ke, atau maknanya the expression is X. Okay, so the expression is X. So put the X as output lah. Okay, put as output. Okay, macam yang kita buat dalam expression ni lah tadi. Okay, macam ni. Okay, macam ni kan. Okay, sebab 0 dengan 9 saja digunakan. 10 sampai 15 ni tidak digunakan. It not being used and not being function pun. Okay, so therefore kita put as X expressions. Okay, so yang the rest tu you boleh draw the plot all the output of one into a K map and get the Boolean expression, and then after that you can draw the circuit diagram. Okay, so that's all for the chapter 4. Okay, I hope you can do the exercise. okay, and do more on exercise of the Canon map, especially on the case studies, okay, because the case studies is different, but the concept is the same, okay. So the concept is when you give a case studies, extract all the informations that given to you, okay, and then put into the logic input and outputs, and then after that generate the truth table, okay, and then after you generate the truth table, then uh, draw the K map for each of the particular outputs, okay, and then from the K maps you can get the simplified or Boolean expression by each of the output respectively, and then you in the end you can draw the circuit diagram based on the given uh, simplified Boolean expressions. Okay, so I hope this schema is very interesting. You can use you need to do more exercise, okay, in the notes and then in the past years, okay, in order for you to get better understanding of this chapter. So that's all for now. Thank you. Assalamualaikum.